Good evening, everybody. Welcome to the first live session. I'm Anirban Rai. I'm a PhD student in IIT Delhi, and I'll be here to give you some extra inputs in the course, clear your doubts, and whatever help that you might need to understand this course better. First, is everybody able to hear me?
Sir, your voice is not audible.
Not audible. Okay.
No, it is audible for me.
Okay. Uh, okay. So most people can, I think. And my camera is not working today, not able to show my face. Uh, I think I'll do that next time. Uh, and like, so first of all, we should get to know each other better when we'll be interacting with each other for some time, at least I think 3 months of this course. Okay. If someone would like to volunteer, uh, introduce themselves and also explain why do they want to do this course, just so that we can know each other better.
Okay, maybe I'll start. This is Suresh Kumar.
Hi,
I'm
Suresh.
having almost 18 years of experience in IT. I'm working currently in backend technologies like Java, Spring Boot, AWS in JP Morgan. So I'm planning to do my career switch. So from last 2 years, I'm doing this machine learning courses. So as part of that, I enrolled for this course. Then I
Wow,
came.
great. Yeah. You have already learned basics of machine learning, I think, somewhere, and now
Yes,
you
yes,
want to move into deep learning.
correct.
Okay. Okay. Uh, Anybody else? Uh, Someone would like to volunteer, or if someone has a doubt, what does the course means, what type of background the course requires, how you will be more successful, those type of questions you can ask as well. Okay. Okay. So I am a PhD student in IIT Delhi. To explain myself better. So I my admission is in School of AI, and my focus is on self-supervised learning and its application in world modeling. And it is a pleasure to be in this course to help you guys. Okay, and any more interactions? If some clarification someone needs, how things will run, or anything like that.
Hello,
Yeah. Yes.
good evening, sir.
Good evening.
My name is Kurnamadi Mahankari, sir. I am from Nasrobeta. I'm a postgraduate student.
Hmm.
Present, I am working a full stack developer using AI.
Okay.
This technology helps for me in future, sir. I have small doubt. This
Okay, you can ask.
suppose this deep learning used for my in future like job purpose.
Whether it will be useful, you want to ask, huh?
Yes, sir. Yes, sir.
Deep learning is a important art, like we are using a large neural networks model to learn
Okay.
pattern in the data. Okay, so wherever that would
Okay.
be applicable, it can be used. Okay, suppose in the business sector, finance sector, you want to find pattern in the data, or uh,
Okay.
or or somewhere else maybe as well. Okay, like in natural language processing, it has been used extensively and quite.
Sir, I have sir, I have one idea. This
Yes.
plan is work or not? Can you tell me?
Uh, so you have a plan. Okay. Okay. Let us hear that.
Yes.
Yeah.
I have. I can develop the AI assistant. For
Hmm.
me, this deep learning is useful or not?
So you want to develop an AI assistant. Yeah. So
Yes.
all the type of AI assistant and mostly as you see are the large language models these days. So they are the
My
AI.
AI is total different, sir.
Pure.
My AI is total different. For example, like
Okay.
in my AI model, handle my phone calls like mobile camera and Wi-Fi signals and also uh, file management and also file creations. This type.
Okay. Okay. But those will also require the knowledge of the system that that means the assistant will require the knowledge of how your system works. Okay, so what you can say
Okay.
it requires a world knowledge of that. Okay, so
Okay.
for that our classical approach of training large models, acquiring world knowledge is what will be useful. And for training large models, you do need deep learning. It is the state of the art. Okay, deep learning is what
Okay.
is used for training large models. Okay.
Suppose I can use a API keys, for example, ChatGPT API key, Gemini API key,
Yes, you can do that. Yeah. So they have the required world knowledge. Yeah. And you can use
but
that
some has a limit.
assistant.
It's a limit purpose. Gemini API, ChatGPT.
So the cost things you have to look at it yourself. I cannot know about that. Okay. Uh,
Okay.
yeah. So yeah, it was nice to meet you. Yeah.
Thank you,
Good
sir. Nice to
idea.
meet you.
Yeah. Thank you. And anybody else, having some unique purposes like Kornepati had.
Good evening, sir. Good evening,
Good
all.
evening.
Myself, Vani, sir.
Good evening.
I'm working in assistant professor in one of the engineering college.
Okay.
So recently, I joined in PhD, sir. So it will be more helpful in my research work. For that reason, I joined this course, sir. I enrolled.
Okay. Okay. Sure. Very nice. Uh,
Thank you, sir.
thank you. Somebody else would like to open up?
Sir, this is Lokendra from BTech second year, sir.
Nice to meet you, Lokendra.
Sir, without doing completely doing machine learning course, can we do this course, sir?
Yes, it is possible. Okay, but so today we'll cover the like necessary basics of machine learning. For deep learning, what happens is that uh, the basics of the machine learning, the fundamentals of the machine learning, mostly the researchers need to use. Okay, because the
Okay, sir.
fundamentals keep coming. Okay, for some suppose you're a bachelor student, you want to apply the things. Okay, so for that, you just need to be knowledgeable in neural networks. It's basic maths, okay? Linear algebra is important, okay? And the bare minimum machine learning that is required, we'll cover that today itself, okay? So
Okay,
so so that will be done, okay? So you can do that without machine learning. Machine learning is not compulsory for deep learning, though it helps in understanding, yes. But you can do
okay,
it easily, actually.
okay, sir. Thank you.
Anyone else has some doubt or something?
Hello, good evening, sir.
Navina, nice to meet you.
Yes, good evening, sir. Nice to hear you. Aniram, yeah.
Yeah.
Sir, basically I'm a faculty working as assistant professor in Karnataka. Okay,
Okay.
my area of interest is in surface defect detection. Okay, so my area of exploration is on finding out defects in surfaces of materials. So as I was exploring that part, so I came to know from my supervisor that some knowledge about computer vision is required. So
So
my
which type
basic
of material you're encountering?
materials.
I mean,
Sir, my area of materials are welding defects, weldings, so
okay.
welding joints,
Okay.
pipes. So on those,
Hmm.
we find some defects, but with expertised only peoples of area will be able to identify them. Okay,
Okay,
so
understood.
some defects will be of, but in purpose, what we want to is atomize that system and make that identification at a continuous process in a continuous process. So for that area I'm working. So well, whether this computer vision will be helping me to explore it more, that is what I
So,
wanted to know, because
yes.
I was guided. Mhm.
Okay.
Tell
So
me.
it is like if you're analyzing images, okay. So computer vision is the
Mm-hmm.
machine learning or deep learning area for images itself, okay. So if you're analyzing images of
Yeah.
defects, okay, so then it will certainly help,
Mm.
okay. So
Yes, yes.
through this course, you can devise your ways how to do that, okay.
Yeah.
Uh, but uh, but for you, I think
Mm.
a machine learning course would also be helpful. I think for some getting the basic
Yes, yes,
understanding.
yes.
You're doing that?
Yeah, yeah. So use, yeah, yeah. I'm doing that one. Have learned some parts in Python programming, and I've been using the data sets. But how to find out the images means with literally, I was not knowing about the what is vertical edges or edge filtering, all those things part. So I wanted to explore it more, so can be very confident enough in knowing the images which are relatively very near to each other. That's what I was trying to explore.
Okay. So
Did
we
you?
we we do cover those, okay, in the week two, as you can see. So there
Mhm.
are those
Yes, yes.
topics here, but most of the course will not be focused on
Mm-hmm.
that, okay. So these were the classical techniques, okay, not deep
Okay.
learning technique. So most of these have been phased out,
Mm-hmm.
okay. This is just introductory
Mm-hmm.
historical focus, okay. But if it is useful for your thing, then most welcome, okay.
Mm-hmm.
So the edge detection and
Okay.
these things have been means what previously people used to
Mm-hmm.
do that what happens is that in deep learning, the features, the important features, okay, that will be important for
Mm-hmm.
our task is actually learned by the model itself, okay. But
Yeah.
previously, what people used to do that they used to design the features, okay,
Yes, yes, yes.
design the features. And in case of
Mm-hmm.
like computer vision, when you want to do different tasks, like you focus on the edge or something, blur or anything. So they make specific filters, okay.
Yes.
So, but uh,
Yes,
but
yes, yes,
but
yes.
but using deep learning, that hard work has been automated. Okay,
Mm,
so people don't need to design filters or
mm,
create features. Okay, so that has been part of the loop itself. You
yes.
just feed the images, and
Mm,
give the supervision according to the task that you want to perform, and the model is able to learn.
mm,
Uh, uh, the type of features a filter that it needs, for the for getting the task done. Okay, so that those have been automated. It is very easy now. Okay, mostly in supervised setting it is very
Yes,
easy,
yes,
but other setting it may be challenging.
yes, yes,
Okay,
yes.
but
Because we
a machine
have
learning course
some
will also
universal
help you.
data
Huh?
sets.
What you say?
Yes, yes. Because we are having, because we are finding that there are some universal data sets. So using those data sets, we can validate the model which we are choosing for our application. So
Okay.
that particular part also I wanted to explore.
Okay,
Mm,
okay. So, so
mm,
everyone, you
mm,
can see
mm,
such diverse applications of machine learning, deep learning, AI, as you can see. So,
mm, mm, mm.
in your student batch itself, you can see that the
Mm.
extreme diversity you're finding, bachelor, second year to PhD to professors,
Yes, yes, yes,
and so everybody wants to learn that, apply it in their field. Okay.
yes.
So someone
Mm,
with 18 years of experience, someone with 0 years of experience,
mm.
everyone here, okay? For everybody, it is applicable in one way or other. And
Okay.
okay, okay, anybody else?
Mm.
In the chat, Madhuvan has
Okay.
reached out. Maybe I
Thank you.
will.
Thank you.
Okay, thank you. So in the chat, I'll present it now. Okay. Madhuvan has reached out, and as you can see, uh, that he's a second year BTech student at Triple IT, uh, Andhra Pradesh, I think, yes, and some image processing project, okay, using computer vision, okay. So he's doing his internship there at IIT Roorkee, okay. So you can see the variety, yeah. Okay, so good luck, yeah. So that will help for sure, yeah. And deep learning is enough for that. I think you don't need to do machine learning, yeah. Okay, anybody else?
Hello, sir. Good evening, sir.
Good evening.
I'm myself Pranay Kumar, and I am currently in third year in integrated MTech at
Okay.
Devi Hindu Vishwavidyalaya, Indore.
Hmm.
And
Nice to meet you.
last I have been doing last 3 months research internship at ISR Bhopal
Okay.
under Dr. Akshay Agrawal, sir.
Okay.
And I have been working on democratic training reference this year in ICLR 2025 conference paper, which was published, was
Nice.
going for the novelty. And so the professor asked me to explore computer vision more. So I had joined this course.
Nice. Nice. Yeah.
Also, we
Very
met
nice.
Vineet sir recently in IIT Indore at summer school.
Okay. Okay, Pranay, very nice. Working on state-of-the-art research. Nice to meet you. Uh, hope this course helps you. Yeah. So we will be focusing on first supervised learning of in case of computer vision, supervised deep learning. Okay. Then we'll move to self-supervised as well. Okay. Here. But the
Yes,
first, the basics of how it was historically done. Okay, that will be there. Deepfake video defense. So if you want to find and check which are the deepfakes, right? Uh, mm, this course may not be too helpful for that. Yeah. Yes. Okay. So anybody else has to share something? Then we'll be starting. Okay.
Hello, hi.
Hello.
So my name is Muhammad Ahmad.
Nice to
I'm
meet you.
currently working in a private organization uh, as a data scientist. So I've been like developing applications where I use LLM in the backends. And my expectation from this course is like uh, my experience in the corporate is not very good uh, because I meet so many people, and when I get to know their technical depth, and so I get very disappointed. So I'm kind of like leaning towards doing masters in AI. So I'm looking for anything that can help me to prepare for GATE, AI and D, DSP.
Okay, okay. So you want to ace the GATE exam and whether this course will help. Okay, so this is basically a deep learning course, but more focused towards computer vision. That's okay. Yes. But we'll be addressing computer vision through the deep learning route. Deep learning is very general, not specific to computer vision. It can be applied to many other domains of AI. Okay, and the techniques overall are similar. Computer vision or NLP or anything. Okay, so it will certainly help. You can take it as a deep learning course, not like a computer vision focused course. Okay, okay. Thank you. Yeah. Anybody else? Yeah. You can unmute yourself. Yeah. From 5:30 we'll start the current. Yeah.
Good evening, sir.
Good evening.
I have completed BE, and after that, have 5 years of experience in IT, but I don't have corporate level experience. I have completed diploma in data science, and I'm looking to complete masters in data science next year. So, for that purpose, I have joined this course.
Okay, very nice. Yeah. Uh, so corporate experience is not required at all. Yeah.
Mm.
Uh, okay. So corporate
Yes, sir.
usually focus on applications. So applications you can do after you get done with the theory part here. Okay. Mm,
Okay.
okay. Yeah. So it'll help you. Yes.
Yes, thank you, sir.
Thank you very much. Okay. So here's Simna. Here is Simna. We have with us. Okay. So she says that. So she is focused on computer vision applied to weather forecasting. Okay, so it is a growing area, and so yeah, so satellite image and yeah, so this course will certainly help. Deep learning is important. Okay, but so the your field like satellite image, working with satellite image, which can be multi-dimensional, not just means three channel images, can be multi-channel images. Okay, and it has its own challenges actually. So this course will certainly help you, but you need to do something else as well. Yeah, which are more focused towards such satellite images work, because the satellite images are different, means are kind of little bit more challenging than the this our everyday images. Okay, RGB images. Okay. Mm. And so there are noise and everything added to the images, and usually they are more noisy. Okay, and the data collection and every challenge is also there, which you need to address. Okay, so domain adaptation is also a challenge. So the domain, what does domain adaptation means in case of computer vision, which is a very important concept actually. So domain adaptation means that when the data that has been used to train the a model. Suppose in your case you're using like satellite images. Suppose you're taking images of fields of China, means like rice fields of China, and using them to predict how much uh, for whatever purpose it may be. So you have a trained model for this type of images. Okay. Now you want to apply that model to the images of rice fields of America, let's say. So the what happens is that both of this collection of data set had a domain gap. Okay. So that model will not be may not be too good at extending to the US images. Okay, so those type of challenges are there. Domain adaptation will be covered in this course as well. I think so. Not too sure actually, not checked everything. Okay, so that is there. Okay, thank you very much. So that's several more challenges are also there apart from deep learning in those type of work. Okay, so you need to explore that. Uh, and AI assistant. Okay, so AI assistant was the same. Yeah, I explained that. Yeah. Mm. So let's without further ado, let's get started and so we'll focus on some basic questions and theories for this. Okay. Uh, First is this derivative and everything. Okay. So not tough. Okay. And so let me get this down quickly. So you need to find the derivative of this. So dy dx and okay, we'll focus on this basic maths and some machine learning concept. As this is a deep learning concept, deep learning course, so just a little bit of machine learning that is required. Has to be done. Okay, and these are very basic thing. So derivative of sine x is cos x, and the derivative distributes. Okay, over the expression. Okay, so with chain rule this becomes this. Okay, so first e to the power x derivative is e to the power x, and after that derivative 2x is 2. Okay, so here half comes over and x to the power minus half. Okay, so this is done. Any doubt? We're quickly done
No, sir.
with the derivative. So next question is this: the tan hyperbolic. So in machine learning, usually what people like to do is that display the result. So this type of functions that we are using here. Uh, so so as you can see in the problem statement, that so there are activation functions. Okay, in neural networks. Maybe someone if has idea. So let me explain still. Okay. So even if like one node of neuron is there and there's this input coming, okay, which has suppose four inputs, okay, one, two, three, four, okay. So means you're giving suppose four values here, okay. So the input is four dimensional, okay, and some output has to be there, okay, and this is the structure. So this is what we call the perceptron, okay. So you can put them in like as a networks, okay. Uh, then it becomes multi-layered perceptron or neural network, okay. And so we do it like that, okay. And what happens is that so you define a hypothesis function with parameter theta here, which is just a vector of theta 1, theta 2 like that, okay, and theta n x n, okay, to introduce non-linearity so that it can learn non-linear decision boundary. We use a activation function. This is the activation function. Activation functions are different types like sigmoid, tan hyperbolic, and ReLU. And so here it is a tan hyperbolic function, okay, and we need to find the derivative of that. And so what happens is that in machine learning we need to usually define the derivative in the terms of the original function. So that is the approach we'll take here, and the final result will be in terms of tan hyperbolic. Okay. So So first the derivative of this. So you would use the divide rule of the derivative. Okay, so derivative first, derivative numerator multiplied by the denominator, so it becomes the square of that, right? Okay, next minus, leave the numerator and then derivative of the denominator. That again becomes the square. Okay, divided by denominator square. So when you divide that, the result is 1 minus tan hyperbolic x square. This is the result we get, right? Done. Any doubt? Okay, Rahul. Rahul, you can unmute yourself. Rahul, you can unmute yourself and ask it. So nothing, I think. Yeah. So let's continue. Okay, no problem. Uh, so derivative of this chain rule and everything by 2, I think it is 2. This is what you have to find, okay? And so you have to use chain rule. So sine becomes cos. So first take derivative of sine, that becomes cos. The inner thing remains the same. Then you take derivative of the inside. So under root x means half comes ahead, and ex plus a to the power minus half. 2 remains at the bottom. Now you have to take in derivative of this inside ex plus a, which becomes ex, because derivative of ex is ex and a is 0. This is the result you get. You can simplify and you'll get it. Okay. Any doubt?
No, sir.
Okay. So let's continue. Basic probability theory is important. Maybe not so much for deep learning, but for machine learning. Which assignment is this? So it is in week 0, as you can see, practice week 0. Okay. We're going to do that this session. I'll follow up on the next weeks on subsequent sessions. Okay, so week 0 is what we focus on this session. Okay, and okay, so this is the question you have. So laboratory. So you're doing. So the situation is the population has one disease. It may or may not have the disease. Means some people have it, some people don't have it. Okay, and there is a test to detect the disease. Okay, and but the test is not foolproof. Okay, it is sometimes able to detect the disease, sometimes not able to. So you're given a probability situation like that. Okay, and what you need to find is the probability that a person has disease given the test result. Okay, given the test, I think okay, it has got cut. So I took the questions from here only. Okay, the test result is positive. Sorry for this. Okay. So if the test result is positive, it is given that the test result is positive. What is the probability that the person has a disease? Has the disease? Okay. So we need to make some variables here. So and so what I do is that probability the person has a disease. Okay. So I have a variable p. Okay. Small p. Okay, which denotes, which is a random variable, which denotes, or maybe you can use a better variable. So let's have a. It is a random variable which denotes the person that we are testing is infected or has a disease. Okay, so a person struggling has a disease. Okay, v is random variable which represents the test result is positive. With the test result confirms that a person has a disease. Okay, these are the two random variables. You need to understand it well. Okay, that a represents a person, the person that you are testing has a disease. Okay, means this is like a truth, I know it, but the test, we do the test as well. Okay, and if the p variable represents, then the test result is positive. Okay, it is a random variable. Okay, so what means that the value of the variable is not certain. Yes, stochasticity. Okay, so this is the situation we have here. Now what we have here is a laboratory blood test is 95% effective in detecting a certain disease when it is in fact present. Okay, so given that a person, so disease is present. Okay, so A is given. Okay, so and okay. Uh, so what I was saying is that so disease is present, okay, then 95% is able to catch that. So means it will give a positive, right? So this probability that B given A is 0.95. Okay. Next, however, the test also yields a fake false positive result for 1% of healthy persons tested. Okay, so what happens is that if a healthy person uh, is tested, okay, but disease is not present. So not what we do is that we bar that, okay. So A is not present, okay. So it gives a false positive, still gives a positive, but the disease is not present, okay. So this probability is 0.01, okay. Done. Next, if 0.5% of the population actually has the disease, okay. So what are they saying is that probability that A, okay, means a person has a disease is only 0.5%, okay, that is 0.005, okay. What is the probability that a person has the disease given the test result is positive? So what you need to do is that the test result is positive. So B, and person has a disease. Okay, you need to find this probability. Understood the problem solution construct? We have not solved it for now. I don't think you need to submit the assignment. Let's see. There's nothing like that, I think. Will not be evaluated or counted towards the final score. Yeah, just a warm-up exercise, you can say. Okay. The solution construct is clear for now. So what we need to do is that we need to calculate this probability. Okay. So you can easily understand what you're going to do is use the Bayes theorem. Okay. So okay. In Bayes theorem, what we have is that P A comma B. So we need to find this can be written as P A B B comma A by PB. This is Bayes theorem, simple. Next, what we're going to do is that so you have PB comma A 0.95 and PA as well 0.005. Okay. Now what is PB? Okay. So PB we get from the sum rule of probability. Okay. So what does it mean is that the PB is equals to PB intersection A plus PB intersection A cap. Okay. So what does it mean if you can understand is that the test result is positive. Along with that, okay, so joint probability that test result is positive the as well as the population has the disease, and then another situation is positive. Along with that, the population does not have the person we are testing does not have the disease. Okay, so this is basic. Anybody has any doubt? We don't know the probability theory. This is the sum rule of probability. Okay, and now what you can do is that you can decompose it further. Okay, how? So you see that PA is given here. Okay, so what we're going to do is that we take the PA out. Okay, and you can write it like PB given A, and next what we have is PA bar PB given A bar. Okay, this is what we're going to do. So this one is same as you can see as this one. This will come here. Okay, plus this is the one PA dash is 1 minus this one, that is 0.995. Am I correct here? Yes. PBA dash, this one is here 0.01. So you put the values, you get the answer. Okay, any doubt? Has anybody got confused in the writing? So this is the thing. Okay, this is the simplification of the denominator. Okay, uh, the denominator one term is same as the numerator. So that is what I've shown here. I hope it is not confusing. Okay, okay, somebody is confused. Okay, okay, let me explain again. Okay, so this is the expression. Up to this, any problem? Who has doubt? Kornepati. Kornepati, can you unmute yourself and guide me?
Sir,
Yes. So this up to this step is clear.
yes, sir.
Okay, now what we are doing is that you can write a so you can write a probable joint distribution. This is called joint distribution.
Okay.
Okay, in the form it can be written as PB
P of PB.
like this, or you can write it as PA into
B by A.
PB by A. Now what I have done is that you can understand PA or PA bar, okay, is given. PA is this, so PA bar is 1 minus this, okay, so that is given, okay. So what you need is you
Okay.
need PA or A bar here, okay. So you need to write it this way, and automatically this becomes B given A, and this become B given A bar, okay. And now the values
Okay.
are given, you just put the values, you get the answer.
Okay. Thank you, sir.
Okay, so clear?
Yes, sir.
Okay, okay. So moving on. Okay. So moving on to this question. Uh, these are the problem we are given. So suppose the first coin is C1, the second coin is C2. Okay. And so encountering the first coin, what will have happen is that what are the possibilities are that you can have HH. So that there are two throws of whatever you get. So if you get okay, let me show you. So what happens? You choose one coin and toss it twice. Okay. So if you're tossing it twice, then you get two results. Okay. HH, TH, HT, TT in case of C. In case of C2, okay. So what you can get is that. So the probability is one. Okay. So you always get head. Okay. So you get only this. Okay. Clear on this one? This is the sample set. Okay. In doubt? No doubt, right? So next is the first toss results in head. So in how many ways? So what I do is that first toss result in head. I write it like FH. So first toss result in head. Okay, so like that I write. Okay, this is the word you need to find. These are not two variable. The single variable, that is how I've written, or for like. Acha. So okay, understood. So next, what is it that? So what I can write is that this can be written as PFH given C1 plus. Okay, so this is no correct, no incorrect, incorrect, sorry. So this is the sum rule of probability. So what happens is that for both the event, sum of the sum of the sum of these probability. Okay, let me explain. So what you have is that so we do it from the set. Okay, so C1 and C2. Okay, and what we have is that first, so you can have okay. So what I'm saying is that mm, okay. So it is something like this. Let's really understand. So first head, this is what represent the first head, okay, and this is represent the coin one and coin two. So these are the thing you need, okay. So to have the total of it, okay, this is what you need, okay. So what you can write it as PC1 into PFH given C1 and similarly the C2 part, okay. Now PC1, so as you can see, you're choosing it randomly, so the probability of getting it is half. Similarly, this one is also half. Okay. Next, what you're having is probability that first is head when it coins when the coin is coin one. So what happens is there are two situations when you get head. Okay. So 2 by 4, right? This is half, and this becomes that. So there's only one situation. This is one. So 1 by 4 plus 1 by 2 is 3 by 4. Answer is 3 by 4. Done? Any doubt? Answer is 3 by 4. Did you understand? Clear? Okay. Next, what you do, the second toss results in head. Okay, so do similarly. Okay, so for FH ki jagah, it will be SH. Okay, and rest everything same. The second that you can see that there are two heads here. Okay, so that it is probability is half into half plus half into 1. Those, so you can understand the second toss is independent of the first toss. The result of the first toss does not determine the second toss. So you can do it this way. A intersection B. So both are head, okay? So 1 by 4, it will become 1 by 4, okay? So what I do is 1 by 2 into 1 by 4 plus 1 by 2 into 1, okay? 1 by 8 and half, what is it? 5 by 8, okay? Like that, you can do it. P A given C. So what is C here? Fair coin is selected. So you select C1 only, okay? And so that will be half, right? And this will be half, okay? This 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 is the one we okay. This is the one we need here. B given C is 1 by 4, okay? P A intersection B given C. So A intersection, acha, both are head, right? Acha, no, this one is half, okay? This is 1 by 4. Last one, okay? Any doubt you can do it, and I skip through it, yes. Means ma did not explain everything, but it has to be done in a simpler same way, that some rule of probability is equals to sum of the intersections, okay? Any doubt? Any doubt? So I'll just take a small break here, okay? 2 minutes and then 5 minutes. Then I'll come back, okay? Do rest of the rest of the thing I need to do some explaining as well, okay? Not so straightforward, okay? So that is what we are going to do now, okay? Okay, everyone, is it audible now? Going to start again.
Yes, sir.
Okay. Uh, so there is some explaining to do as well now. So this probability statistics part is done. Next we have is the information theoretic part. Okay, so this is entropy, cross entropy, and Gale divergence. Uh, so as you can see that the Gale divergence between two distributions P and Q. So intuitively what Gale divergence means is it measures the distance or distance between two distributions. So what it means by that is that how similar the two distributions are. Okay. So was it? Okay. So so that has been represented as the sub difference between this cross entropy and entropy. Okay. So HP comma Q is the cross entropy here, and this is HP is the entropy. This is the Gale divergence. Okay. So they have derived the formula for the Gale divergence. Okay. So for every x sampled from the distribution P, you're calculating this. Okay, and summing them over. So you can see the derivations as well. So what we're doing is that so so derivation is straightforward. I think there's nothing complicated in that. And so dl and q with respect to p is also shown. Both are not the same, as you can see. Okay, so Gale divergence is not symmetric. So it's an important result actually, which comes handy sometimes. But Gale divergence is not too useful in deep learning. Yes, but we are still doing it. Yeah. So So this is the question you have here. Uh, so you need to find Gale divergence between P and Q. Okay, and this is the problem statement we have. So how are we going to address that? Uh, okay. So this is what we have. So the formula is X is sampled from P distribution and the P log P by Q. Okay. This is the Gale divergence between P and Q. Okay. So there are three values of x1, x2, x3, and px becomes 0, 1, 0, 1. Okay, so if we have 0 here, that this will become 0. Okay, so only one term remains, that is 1 times log of p by q. So p becomes 1, q becomes 0.25. That becomes log 4. Okay, this is done. Any doubt? Okay, moving on. Next question is mutual information. Okay, so mutual information has been defined as this. Okay, uh, so it is joint distribution. So in KL divergence, you had the only that P there, but here you can see it is the joint distribution between x and y multiplied log of joint distribution by the individual distributions. Okay, this is how it has been defined, and you have to prove that the dimensional information I x comma y is hy minus hy given x. Okay, y given x is the conditional entropy of y given x. So this is the problem statement you have here, and so it is not very hard to solve, as you can see. Some steps and you'll arrive at the solution. Any doubt in this? How it is happening? So what we have done here, as you can see, is first you've separated that py part, okay, okay, from this, and that results in these two expressions, okay. Why we have separated the py part? As you can see that we need hy here, and this turns out to be hy, okay. So if you focus on this term here, what you can get is that, so here we are summing over x, okay. So a joint distribution of x and y, if summed over x, because this y is independent of x, right? So the sum is just over this, so it becomes a marginalized. So this is called a marginalized distribution over y, okay. Means the x has been integrated out or summed over, okay. Okay, so in sum over x, the x does not remain, only y is there, okay. So this becomes, okay, and this is what is, this is the entropy, okay. Next we go from here, okay, and here what we do is that you can write a joint distribution in the form of this, in the conditional distribution form, which we have done before, okay. And okay, so in the log way, uh, okay, and if you write this in the conditional forms, then px gets cancelled. Okay, so you're left with this. Okay, and now we're summing over y. Okay, so this becomes the conditional entropy. Okay, you're conditioning on x here. Okay, now we're summing over. Okay, you're doing this summing over x, so this becomes the conditional entropy. Okay, okay. Any doubt? No doubt, right? Next, a important concept of linear algebra, which is norms. Okay, norm of a vector, which is quite important in deep learning, honestly. So it is defined like this. Okay, so this is the n-dimensional vector. So it is sum over the modulus. Modulus is very important here. Okay, so modulus over each of the component. Okay, power to power p, sum them over n, and then raised to the power 1 by p. So substituting this, so you can see the different norms. These are the important ones: L1, L2, and L infinity. L0 is also there. Okay, these are the important one. You can see the calculation. Calculation is not difficult, but the concept is difficult. Is important. Okay, so this is the norm of a vector. Okay. Next is linear independence. Okay, and rank. So which of this set of vectors are linearly independent? Okay. Okay, so what does it mean? That uh, one cannot be written as the linear combination of the other two. Okay, so for that, what we do is that we have so we assume there are variables. Okay, v1, v2, v3. Okay, and not variables. say scalars are there. Yeah, so scalar variable a1, a2, a3. So what does it mean? Let me explain. So so this becomes so this is given to you, okay? And and uh, and you have to understand whether v1, v2, v3 is so v1, v2, v3 are not all together zero, okay? Cannot be zero at all at once. So they are not, as you can see, they are also not not all are zero in these examples as well. So v1, v2, v3 are the vectors, okay, of the set, as you can see, and this is only possible if a1 a1 equals to a2 equals to a3 equals to 0. Okay, all have to be 0. Only then this sum will become 0. Otherwise, not. So then they are linearly independent. Okay. So what you do, you write it in this combination. So you get 4a1 for the first equation equals to 0. So that means a1 equals to 0. So similarly, a2 equals to 0. Similarly, a3 equals to 0. Okay. So they are linearly independent because only in this situation this becomes 0. Okay, according to the definition, okay, of linear independence. Any doubt? Any doubt? This is the definition of linear independence, that you're given a linear combination of three vectors or maybe n number of vectors, here 3, is equal to 0 only when each of the coefficient is 0, also given that none of the vectors are 0 all at once. Okay. Next you have this one. So you have a1 plus a2 plus a3 equals to 0. Uh, yeah. Next a1 plus a2 a2 plus a3 equals to 0. a3 equals to 0. So a3 is 0. So a2 is also 0. a2 and a3 are 0. So a1 is also 0. So all of them are 0. That means linearly independent. Okay. Next, this question you have. So this becomes a1. So you have to write it in the form of equation. Just moving forward quickly. 2a3 equals to 0. Okay. Next, what you have? a1 plus a2 plus a3, 3a3 equals to 0. a1 plus 2a2, 2a3 equals to 0. Okay. So now what you have is there. So these two equations are same, right? They are redundant, you can say. Okay, so you're left with this. So you can element a1 from this. So a1 can be anything. Okay, so that means that a1 can be anything. All are. Okay, a1 is not important, and uh, we get a2 plus a3 equals to 0. Okay, that means that if a2 we are given, then a3 is minus a2. Okay, so you can get one combination in which not all of them are 0. Suppose a1 is 1, a2 is say 1 and minus 1. Okay, so this is a valid one which will satisfy this expression, but this expression is not satisfied. Not all of them are 0. So this set is not linearly independent. Okay, they're linearly dependent. Okay, and also you can write it like this. Okay, suppose double of this. Okay, this becomes 4, 2, 2, and add this 1 here to 4, 3, 2. It becomes, you can write as a linear combination of the other two. Okay, this is done. Any doubt? So, rank of a matrix. So you can see rank is defined as the minimum number of linearly independent rows or columns. So just take these vectors like previously you have taken and find how many of them are linearly independent. And then you can do it. Another stylish way to do it is that so you have any matrix, say 1, 2, 3, 1, 4, 5, 2, 3, 0. Okay, so 1, 2, okay, correct, clear. So what we do is that you have to make this means this you have to make try to make these three zero. Okay, one is already zero here. Rest what you do is this one is 0, 2, 3. Uh, okay, and you take this one and double it and subtract. Then this becomes 0. 1, 2, 3 remains. Okay, so double it so this becomes 0 and this becomes minus 1. Okay, and this one you can still not make it 0. Okay, so this is the final result. So now the number of non-zero rows is 3. So rank is 3. It's another way of doing it. Okay, any doubt? Okay, moving on. Eigenvalues and eigenvectors. So this is the expression for this lambda is called the eigenvalue. X is the eigenvector. Okay, A is the matrix at question. So this is the matrix. Okay, so for finding the eigenvalues, what you do is that you subtract you solve this equation. Okay, and then you get the eigenvalues. You put the eigenvalues. Okay, and you get two equations in a. There are two dimensions, so x1, x2, the two variables as well, and you can find the eigenvectors. Any doubt? Anybody has done this? This part is not clear to most people, I think. How do you get to this one? Okay. So they do is that you can see, so they are linearly dependent equations. Okay. So what it means is that you fix one, suppose you fix x2 here to 1, and then you get x1 as 3, as 1 by 3. Okay. That is how you get this one. Next is this question. So what we have to prove is that you have to prove this x transpose x is equals to x transpose x multiplies x. Okay, so what is written? X is a vector that is given. So you have to prove that x transpose x is the eigenvalue of the matrix this. So this is the matrix. In place of A, you put x transpose. Okay, so that is what they have done. Uh, yeah. So this is matrix A here. So they have put it right there. And then x vector is a vector. And so you can compare with the expression here. So a into x equals to lambda into x. Okay, so you put that lambda is this value. Okay, eigenvalue x transpose x, and x is a vector. So what they have shown is that we have to show that these two, this one and this one, are equal. Okay, so they start with this expression. What they do is that So you can write it like that. So you can separate this x1 out and this x transpose x. You can write it like this. Now x transpose x is a scalar. We can move that forward, okay? And this is the vector x, okay? This is done like this. Any doubt? No doubt, huh? Okay, so continuing, what you have is a. So you're given this. It's not too tough. Some simplification is required to get the answer. This one is clear. So for several lambdas, several eigenvalues, you can have a eigenvalue expression. Okay, this is the one, and then you need to find the eigenvalues of the matrix this. So you are given this, you need to find the eigenvalue. So you have to write it that the lambda x form. Okay. So what they do is that you can put the x inside. Okay. I x is xi and a xi is lambda I xi. So they have written that one. Now take lambda I is a scalar, so they take it forward. Again a xi, that is lambda I xi. So this lambda I lambda becomes lambda I square. This is the result. So this is the eigenvalue lambda I square plus 1. Okay, simple enough. So they define the singular values and singular vectors. So what they do, so what it means is that the singular values are the eigenvalues of the matrix A transpose A. Okay. So this is quite important in singular value decomposition, principal component analysis, those things, but not so important for deep learning. Okay, deep learning, these things are not so much useful, not used. Okay, so but this is it. Okay, so singular value are the eigenvalue of A transpose A, and singular vectors are the eigenvectors of A transpose A. This is the definition. Okay, numerical methods, Taylor series. So these I think you know, very basic things. Now, a little bit of machine learning, okay. So L2 and L1 regularization. So what they do is that uh, this is like a very short writing. Maybe I should. Well, there's lot to L1 and L2 regularization. So what it means is that so L1 regularization helps in a sparse model. L2, and what it means is that you have less parameters to train. Okay. Okay, so a linear model, a simpler model, okay, and L2 regularization will we get this nodes? So nodes are there in the this assignment only. From there, I have picked it up. Okay, it is already with you. Actually, you should just check. So L1, L2 regularization is not so simple. Actually, cannot do it like this overall. Mm, but to understand the basics, what we need to understand is that what people do is they attach. So the problem is that in machine learning and deep learning models, they have a tendency to overfit. Okay, so what happens? Uh, so what happens to control that so that it does not overfit? We do regularization. Regularization does what it does is that it appoints a larger parameter values for every one of them, every one of the parameter. Okay, so for that, what it does is that, so you have a loss function j and it overfits. Okay, so this loss function is not working so well. Okay, what they do is that for every theta j, they, if it is a L2 regularization, they square it up. Okay, sum over all the I and j. I is the layer, j is the column depth. It is okay, and then they use a lambda of how much regularization you want. Okay, and so this is the structure of the L2 regularization. And if it is L1, that put the mod, remove the 2. Okay, like that. So they do it like that. So they are already assigning some value to the theta. Okay, so that the, if some thetas are which are not so important, they are made equal to 0 or close to 0 in case of L2 regularization. So this is one important thing. Another is the mean squared error and least square regression. So this is the mean squared error. So you can see we are meaning averaging over, so that is a mean, and then we are using the square error. Okay, so this is one of the loss function. This loss function I explained here. This is one of the loss functions used here. Okay, so this is it. And next, what we have is, so we take the derivative and of this loss function, and this actually, what is this gives us the gradient descent algorithm. Okay, and well, these are not explained in one lecture, one session. Uh, so this gives us the gradient descent algorithm. So what you're doing is you're taking gradient of the loss function. Okay, this helps us training the parameters, fitting the parameters of the model to fulfill according to the data set. Okay? Next is principal component analysis. What we do in principal component is that you have a high dimensional data and you reduce, but only some combinations of those dimensions is useful. So you do principal components to determine which, suppose 4 or 5 principal component or whatever it may be, is enough to explain the full data. Okay, so you do the dimensionality reduction technique. Okay, this is called PCA. Okay, and singular value decomposition is important for calculation of PCA. Okay, this is the unsupervised method. Okay, cannot go to the depth of this, you must understand for now. And this is logistic regression. So there was linear regression before, least square regression. As you can see, this is linear regression. Okay, logistic regression helps in classification problem. Okay, so that is this. SVMs is another type of classification architecture. Okay, these are far more complicated. Don't want to get into this. ADA boost is type of decision tree algorithm. That's also out of the scope. Okay, Gaussian mixture model is or something I can explain better. It so a single Gaussian distribution is not able to uh, model the distribution of data. So you need multiple combinations of Gaussian distributions to explain the data, and that is called Gaussian mixture model. Okay, so this is it. Okay, uh, I hope you enjoyed this. Okay, many of the things I could not get into depth of, just moved them over. Okay, because these are something you cannot learn in this one lecture. Okay, I think it is time to end it. Okay, any doubt? Anybody else?
Hello, sir.
Hello.
Sir, you discussed about many mathematical concepts.
Hmm.
Yeah. Uh, hello, sir.
हाँ
This
बोलिए.
is Deepak. This is Deepak. While learning this machine learning for computer vision, is it really required, or we have to undergo these kind of mathematics first and then we have to take this course?
So let me explain that one. So taking the derivative is certainly useful thing. Okay, you should be able to know that. Okay, probability statistics like these are quite basic actually. No, uh, hope you know this Bayes theorem. This level of should be known. Scale divergence, if you could not understand, that's okay. Actually, not that important for this course. Mutual information also not important. This linear algebra, norm of a vector, these are important. Okay, so you do this. This is also important. This is important. Singular, if you like could not, then that's okay, but it is nice to know. Okay, and rest of the things, Taylor series are not that important. L2, L1 regularization you must know here. I think maybe in the course as well. This regression, mm, if you can know, that's good. But principal component analysis is not required. Okay. Logistic regression, a little bit of understanding is better to have. SVM is not required. Okay. ADA boost is not required. Gaussian mixture model is not required. Okay.
Okay. Okay.
Anything else? Nothing else. Okay. So you're finishing it over. We'll meet in next week. Okay. Thank you very much.